Imagine walking into your boss's office, right? You've spent the last 3 years and probably tens of millions of dollars of company money building this highly experimental, secretive project.
Oh, yeah. High stakes.
Very high stakes.
Yeah.
And you sit down, you open your laptop, and you present absolute, undeniable mathematical proof that the project you've dedicated your life to is a complete and total dead end.
Just a total failure.
Yeah, like it will never work. Commercially, it's just a disaster. Now, in almost any corporation on earth, this is the day you get fired.
Oh, absolutely. You'd be packing up your desk in a cardboard box that afternoon.
Right. Security escorts you out of the building.
Okay.
But at the company we are talking about today, you don't get fired.
No, you definitely don't.
Instead, you are handed a massive cash bonus, the executives throw a party to celebrate your intellectual honesty, and you're immediately handed a brand new project.
It's just wild. It completely inverts the standard corporate incentive structure, It's an engineered solution to the sunk cost fallacy.
And it is just one piece of this fascinating machinery we are breaking down today. So welcome to a brand new deep dive.
Glad to be here.
Today's date is May 19, 2026. And if you follow the tech world, you already know this is a massive day.
Oh, huge.
Yeah, Google I/O 2026 just wrapped up at the Shoreline Amphitheater in California. And we're looking past all the shiny keynote presentations to dissect the actual underlying DNA of Google and its parent company, Alphabet.
Right, because the real question is how they do it.
Exactly. Our mission today for you, the listener, is to explore how a massive, mature corporate behemoth manages to keep innovating at such a relentless scale without, collapsing under its own weight.
Because it is the ultimate structural anomaly. Usually corporate physics dictate that a company trades agility for stability as it scales.
Right, they get slow.
Exactly. It becomes a victim of its own success, bogged down by bureaucracy, obsessively protecting its legacy revenue streams.
Like holding on to what already works.
Yeah, but Alphabet has somehow engineered an architecture that actively resists that gravity.
Okay, let's unpack this. We are taking you on a journey from the absolute cutting edge of the AI agents announced today, down through the custom silicon hardware that runs them, and straight into the graveyard of Google's failed moonshots.
It's going to be a fascinating ride.
But before we can understand the engine, we have to look at the sports car that just rolled off the assembly line.
Right, the keynote.
Yeah, the core theme of today's keynote was monumental. We are officially shifting out of the era of reactive chatbots and entering what they are calling the agentic era of proactive multimodal AI agents.
And what's fascinating here is the distinction between a chatbot and an agent. It is paramount here.
Okay, break that down for us.
So for the last few years, we've been operating in a paradigm of stateless interactions. You type a prompt, the chatbot predicts the next string of tokens, generates an answer, and then effectively goes back to sleep.
Right, it doesn't remember anything unless you remind it.
Exactly. It has no continuous executive function. An agent, however, maintains state. It has memory.
So it knows what you were doing yesterday.
Yes, and it can formulate multi-step plans. Crucially, it is empowered to take autonomous action across different digital environments.
And the star of the show for this new era is Gemini Spark.
Yeah, the pitch today was basically the ultimate always-on personal assistant.
But always on doesn't mean like a passive voice assistant waiting for you to ask about the weather. We are talking about proactive intervention.
Right.
The demos showed Gemini Spark organizing chaotic project notes into structured databases, proactively updating study guides based on a student's evolving coursework, and monitoring financial accounts for subscription anomalies.
And the big one, the Instacart demo.
Yes. Navigating the back end of an app like Instacart to actually set up and execute grocery deliveries.
The technical leap required to execute that last part cannot be overstated.
Really? Why is that harder than just writing an essay?
Because for Gemini Spark to navigate a third-party ecosystem like Instacart, it cannot simply rely on generating text. It requires a highly robust API orchestration layer.
Meaning it has to talk directly to other software.
Exactly. The AI has to understand the visual layout of an application, translate your ambiguous natural language into precise computational commands, and authenticate securely across platforms without exposing your credentials.
And it has to handle edge cases, right? Like what to do if the exact brand of milk you want is out of stock.
Right. Without hallucinating an order of, 500 watermelons, it is bridging the gap from semantic understanding to real-world execution.
Which brings us to the other massive reveal today, Gemini Omni.
Oh, this was incredible.
If Spark is the executive assistant organizing your life, Omni is the creative powerhouse. It's a new multimodal model family fundamentally designed to create anything from any input. It's completely replacing their previous video model, VO.
And there was a lot of skepticism leading up to this.
Oh, yeah. A lot of people in the tech community jokingly compared the hype around this to Nano Banana. You remember that viral closed-source text model from a few years back?
The one that promised to revolutionize coding but ended up being incredibly limited in production?
Yes, exactly.
Yeah.
But Omni actually delivered on the stage today. The input flexibility is insane.
You can feed it a massive context window of text plus like 5 different reference images.
Yeah, in a rough audio track and a low-resolution video clip.
And it synthesizes all of those diverse data types to generate high-resolution native video.
But the generation itself isn't even the true breakthrough, is it?
No, not at all. What's fascinating here is the disruption lies in the conversational, iterative editing capabilities.
Yes. This blew my mind. It's like being a film director rather than just a screenwriter. You don't have to rewrite the whole script to change the lighting in one scene.
Right. Let's say you generate a complex scene. In the early days of AI video, if you didn't like the background lighting, you had to rewrite the entire prompt from scratch.
You just had to roll the dice and pray the latent space spit out the same main character in the same camera angle.
Which it almost never did. You lost all temporal consistency. The spatial relationships would just collapse.
But with Omni, you don't re-roll the dice. You just talk to it. You look at the generated video and say, keep the character's exact performance, but change his jacket from leather to denim and make it rain in the background.
And it isolates those variables perfectly.
The changes build coherently. You can shift camera angles on a generated subject as if it were a 3D model, stabilize shaky footage, or completely swap wardrobes while the character is mid-sentence.
This represents a profound evolution in machine reasoning.
How so?
To achieve this kind of localized, iterative editing, the neural network is no longer simply predicting the next logical pixel in a sequence based on training data.
Right.
It is actually constructing an implicit, multidimensional simulation of physics and real-world geometry.
I want to focus on one specific demo they showed that perfectly illustrates this physics simulation because it was breathtaking.
The mirror demo.
Yes, they showed a generated scene of a human hand hovering over a standard glass mirror. And then, using only a conversational text prompt, they told Omni to turn the mirror into a liquid surface.
And the AI didn't just warp the pixels, it generated accurate fluid dynamics.
As the hand moved, the liquid rippled, and the reflection of the hand accurately distorted across the surface of the ripples in real time.
Exactly. To render that, the AI has to mathematically understand light transport. It is effectively performing real-time ray tracing.
Wow.
Calculating how light rays bounce off a hand, hit a fluid surface, refract through the simulated water, and reach a virtual camera lens.
It has to intuitively apply the Navier-Stokes equations for fluid motion just to figure out how the ripples should propagate.
Right. It is running a physics engine natively inside a neural network, manipulated entirely by natural language.
They also showed a professor doing a complex trigonometric proof on a chalkboard.
That was great.
The chalk writing was spatially perfectly consistent. The letters didn't morph into alien symbols as his hand moved across them.
Right. Spatial consistency has always been a hurdle.
And they had bioluminescent plants glowing perfectly in sync with the acoustic frequencies of a harp being played.
Oh, and the style controls. Taking a photorealistic street scene and instantly shifting it into a voxel style.
Yeah, and for those listening who might not know, a voxel is basically a 3D pixel like a block in Minecraft.
And it maintained the exact physics and motion of the realistic scene, but rendered it entirely out of 3D cubes.
It's professional-grade visual effects compositing driven by conversation.
And this intelligence isn't confined to video generation. It is bleeding into their core commerce and search infrastructure.
Right. They announced the biggest upgrade to the Google search box in a quarter-century today.
It's a massive shift.
They showed off Ask YouTube, which uses Gemini to parse the video timeline and drop you at the exact 5-second segment that answers a highly specific technical query.
And they rolled out the universal cart.
Tell us about the universal cart.
It's a fascinating strategic maneuver. It is an intelligent, cross-platform shopping cart powered by Gemini.
So it tracks deals across apps.
Exactly. It tracks an item you look at in search, monitors its price drops while you are watching a review of it on YouTube, checks for compatibility with items you already own by scanning your Gmail receipts, and alerts you to restocks.
It is ambient commerce.
Yes.
But the true definition of ambient computing came with their massive push into wearables and Android XR.
The smart glasses.
Yeah, they announced new smart glasses. But what's brilliant is that they didn't try to build a bulky sci-fi helmet.
Right. In partnership with Samsung, they are launching audio-only glasses this fall.
Audio only, so no screen.
No screen. There is no heavy optical projection system. It is just all-day private audio access to Gemini.
And they partnered with Warby Parker and Gentle Monster for stylish frames, right?
Yes. And for the visual side, they teased Project Aura, their advanced AR glasses.
That demo was wild. A user literally just looked at a local coffee shop, the glasses recognized the physical storefront, integrated with the user's phone, and Gemini placed their usual coffee order via the shop's API before they even walked through the door.
This is the physical manifestation of the agentic era.
What do you mean?
Well, Google recognizes that the smartphone, as a form factor, is a bottleneck.
Having to pull a rectangle out of your pocket.
Exactly. Unlocking it, opening a specific app, and typing with your thumbs is high friction. They want Gemini to be a proactive layer draped over your physical reality.
Computing is no longer a destination you visit. It is the environment you operate within.
That's the vision.
I have to pause, though, and push back on this vision for a second.
Yeah.
We are talking about Gemini Spark managing our schedules, Universal Cart tracking our purchases, and glasses whispering in our ears to order our coffee.
All right.
Is this actually helpfulness, or are we just quietly outsourcing our entire executive function to an AI?
That's a very fair question.
If an agent is constantly anticipating my needs and executing them before I even articulate them, at what point do my own decision-making muscles start to atrophy?
That is the central tension of the next decade of technology.
Yeah.
The utopian promise of ambient computing is that by offloading the logistical friction of daily life, the mundane scheduling, the tracking of price fluctuations, the database management, we free up our cognitive bandwidth for higher-order creative and strategic thinking.
But the risk of atrophy is real.
It is. If the AI handles all the micro-decisions, do we lose personal agency? Google's operating thesis is that this is the ultimate empowerment tool.
But the societal impact of having a proactive intelligence constantly intervening in our physical environment is something we are going to have to navigate without a map.
Definitely.
And what's truly mind-bending is the sheer scale of this operation. Running a real-time neural physics engine that can simulate liquid ripples while simultaneously orchestrating API calls for millions of users' grocery orders, while processing ambient audio from millions of pairs of smart glasses.
It's a lot.
That isn't just a software challenge anymore. It is a thermodynamic problem.
Precisely. You cannot just rent that kind of infrastructure. You cannot buy it off the shelf from a third-party vendor.
Right. If you want to process that much data in real time, you have to build the shelf yourself.
Exactly.
Which transitions us perfectly into the bedrock of Alphabet's strategy, the foundation of scale. We have to talk about TPUs and vertical integration.
To run these frontier models, Alphabet is funneling hundreds of billions of dollars into AI infrastructure.
And the only reason they can afford to do that is because of the massive continuous cash flow generated by their core advertising business.
Capital is the prerequisite for playing the game at this level.
Yeah.
Training a model like Gemini Omni requires immense energy demands and highly specialized data centers. But Google foresaw this computational bottleneck over a decade ago, around 2013.
2013. That is ancient history in the tech sector.
It really is.
Most companies were just figuring out how to monetize mobile apps, and Google was already looking at the physical limits of hardware for machine learning.
They realized that the standard silicon of the era, specifically GPUs or graphics processing units, were not going to be efficient enough.
Now, to be clear, GPUs are incredibly powerful.
Oh, absolutely. Companies like NVIDIA have built absolute empires on them.
Right.
But GPUs are, by design, somewhat versatile. They were originally built to render polygons for video games.
They handle parallel processing beautifully, but they still have overhead.
Yes, they have to constantly fetch instructions and read and write to memory. Google realized that for deep learning at global scale, they needed chips that did one thing perfectly.
Massive matrix multiplications.
Exactly.
So instead of relying solely on the open market, they decided to design their own custom ASICs application-specific integrated circuits. They called them tensor processing units, or TPUs.
They deployed the first generation internally in 2015.
Wow, 11 years ago.
Yeah, and today they are on their 8th generation. they have bifurcated the architecture.
What does that mean?
So they have the TPU-8T, heavily optimized for the training phase, where the model ingests massive data sets to learn the underlying patterns of the world.
Yeah.
And they have the TPU-8I, heavily optimized for inference.
And inference is when it actually generates the answer for the user, right?
Right, exactly. Which is the high-speed execution phase, when a user actually asks the model to generate a video or summarize a document.
And they don't just plug these chips into standard server racks. They link them together into massive supercomputers called pods.
The pods are unbelievable.
I saw a stat that these pods deliver exaflops of computing power.
Let's put that into perspective for a second.
Yeah, let's. An exaflop is 1 quintillion floating point operations per second. If you took every single human being on Earth, all 8 billion of us, and had everyone solve one complex math problem every single second, nonstop.
It would take the entire human race roughly 4 years to calculate what one of these TPU pods does in 1 second.
The scale is almost incomprehensible to the human mind.
It is, but the secret isn't just the raw power, it's the architectural control. Google owns the entire vertical stack.
Right, from the custom silicon chips to the data centers that house them, to the software frameworks like JSX used to program them, all the way up to the Gemini models, and finally the consumer interfaces like search and docs.
Vertical integration allows for aggressive optimization.
How so?
Let's look at how JX software works with the TPUs. Because Google controls both, the software compiler knows exactly how to schedule the matrix multiplications to keep the tensor cores on the hardware fed with data at all times.
So there's no waiting around.
Right, virtually eliminating idle compute cycles.
But perhaps the most staggering innovation in their infrastructure is optical circuit switching.
This is pure engineering brilliance.
Let's dive into this because this sounds like science fiction. Traditional data centers use massive, heavy copper cables to connect thousands of servers so they can talk to each other.
Exactly, and copper has severe limitations.
Pushing electrons through copper creates electrical resistance.
And resistance generates immense heat.
Right.
That heat requires massive, multi-million-dollar liquid cooling systems to prevent the data center from literally melting down.
Furthermore, transmitting data electronically over copper introduces microscopic latency,
which cascades into massive delays when you are training a neural network across 10,000 chips.
It's like trying to route millions of cars through a city grid. No matter how many lanes you build, the friction of the roads and the traffic lights will eventually cause gridlock.
So Google completely abandoned the roads.
They just got rid of them.
Instead of copper wires and electrons, they use lasers and mirrors.
It is brilliant. In an optical circuit switch, data is transmitted as photons light via fiber optics.
And when the data reaches the switch, instead of being converted back into an electrical signal to be routed, it hits an array of microscopic, adjustable MEMS mirrors.
Tiny mirrors.
These tiny mirrors physically tilt and rotate in fractions of a millisecond to reflect the beam of light directly into the correct output fiber.
It's beaming the cars from rooftop to rooftop at the speed of light.
Exactly. Light has no electrical resistance. It generates virtually zero heat at the switch.
The bandwidth is astronomically higher and the latency is negligible.
By completely controlling this physical infrastructure layer, Google radically reduces their cost per intelligence.
They don't have to beat standard hardware vendors chip for chip on raw spec sheets. They beat them on systemic thermal and network efficiency. They are winning on ecosystem systems.
That's exactly right.
But I'm going to challenge the underlying premise here.
Oh, go ahead.
Having infinite piles of advertising cache, custom lasers, and custom silicon does not automatically equate to innovation.
That's true.
We have an entire graveyard of telecommunications companies and legacy tech giants from the 90s that had infinite resources, owned their entire physical stacks, and just stagnated.
They turned into giant, slow-moving utility companies.
Exactly. Resources usually breed complacency, so why hasn't Alphabet succumbed to that?
It's a vital question. Capital is just latent energy. It requires a highly specific human architecture to direct it.
And that brings us to the structure of Alphabet itself.
Right. They utilize a massive matrix management structure combined with aggressive flatness.
Let's explain how a matrix structure actually functions on the ground for you guys listening. In a traditional military-style hierarchy, you report to one boss, who reports to one boss, all the way up the chain.
It's rigid.
Very rigid. But in a matrix organization, an engineer working on Gemini Omni might report functionally to a senior director of machine learning who ensures their technical skills are sharp.
But they simultaneously report to a product manager dedicated specifically to the Universal Cart project.
Right. It allows the company to dynamically allocate talent across different products without permanently changing the organizational chart.
And the flatness is a deliberate attempt to eliminate the layers of middle management that typically block information flow.
They want the engineer writing the tensor algorithms to have the shortest possible path to the executive making the product decisions.
But the most consequential structural shift in the company's history occurred in 2015 with the creation of Alphabet.
This was when they officially separated their highly profitable core operations, search, ads, YouTube, cloud, from what they called their other bets.
That separation of concerns is the firewall against the innovator's dilemma.
Explain the innovator's dilemma in this context.
Imagine you are a senior vice president at a massive tech giant. Your bonus and the stock price of the entire company depends on you hitting a 15% revenue growth target this quarter.
Okay, stressful.
Very. Now imagine you also have a team working on a highly experimental quantum computing project that will not generate a single dollar of profit for 10 years.
Right.
When the end of the quarter approaches and you are short on your revenue targets, human nature dictates that you will defund the long-term quantum project to prop up the short-term advertising numbers.
The urgent always cannibalizes the important.
Exactly. By separating the moonshots into legally distinct other bets under the Alphabet umbrella, they insulate those fragile 10-year research projects from the crushing gravity of Wall Street's quarterly profit expectations.
Which sets the stage for a culture of deep psychological safety.
Right.
The sources highlight that the internal operating system of the company actively rewards effort and intellectual rigor over pure outcomes.
But a culture is ultimately a reflection of its leadership.
And since 2015, that leader has been Sundar Pichai.
Pichai is fascinating because he defies the archetype of the Silicon Valley visionary.
He really does. He doesn't have a history of throwing temper tantrums in boardrooms.
He doesn't go on late-night combative social media rants.
Right. He has a deep product management background. He famously led the successful development of the Chrome browser.
His leadership style is universally described as calm, empathetic, inclusive, highly pragmatic, and heavily reliant on consensus building.
He sounds more like a top-tier coach than a dictator.
He does.
But here is the friction point. In an AI arms race, where competitors are aggressively launching new models and taking massive public risks on a weekly basis, is a slow, consensus-driven, pragmatic leader actually a liability?
The common critique.
Does that calmness lead to moving too slowly when the paradigm is shifting?
If we connect this to the bigger picture, it misinterprets the physics of managing a trillion-dollar enterprise.
How so?
Think about it like load balancing in a massive distributed server architecture. If you have a tiny startup, a single server node, it can run as hot and chaotic as it wants.
If it crashes, it only affects itself.
But Alphabet is the master controller for the digital lives of billions of people. It operates under intense global regulatory scrutiny, antitrust investigations, and profound data privacy expectations.
If Alphabet moves too fast and breaks things, entire economies feel the impact.
Precisely. Pichai's bold and responsible doctrine isn't just corporate speak, it's a necessary survival strategy.
His emotional intelligence and calm demeanor provide the bedrock of psychological safety at scale.
If you want thousands of PhD engineers to take massive intellectual risks to invent something like optical circuit switching or conversational physics engines, they cannot operate in a state of primal fear.
Right. They have to know that a failed experiment won't result in their public humiliation or immediate termination.
Pichai's steady hand enables radical technical innovation underneath a calm corporate surface.
And the financial markets validate this approach, right? Under his tenure, Alphabet's value has tripled.
And he successfully reoriented the entire massive fleet to an AI-first footing years before the generative AI boom became obvious to the rest of the world.
So, you have the capital, you have the custom infrastructure, you have the structural firewall, and you have the psychological safety from the top down.
But there is one final critical ingredient that engineers need to actually invent the future.
They need time.
Yes.
You cannot dream up a conversational video engine if your calendar is blocked with status meetings and bug-fixing tickets from 9 a.m. to 6 p.m.
You really can't.
Which brings us to one of the most famous and ultimately tragic corporate innovation experiments in tech history, Google's 20% time.
It is a foundational piece of Silicon Valley lore.
Tell us about the origins.
So the policy, codified early in the company's history, allowed employees, specifically engineers, to spend 1 day a week, or roughly 20% of their paid working hours, exploring self-directed projects that they believed would benefit the company.
Crucially, these projects did not have to align with their actual job descriptions.
Right. The concept was immortalized in the 2004 IPO letter from founders Larry Page and Sergey Brin.
Now, they didn't invent the concept out of thin air, right?
No, they were highly inspired by 3M, the massive manufacturing and materials science company,
Which implemented a 15% time policy decades earlier.
a policy that famously resulted in an engineer inventing the Post-it note while trying to find a use for a highly unsticky adhesive.
The philosophy driving 20% time is decentralized innovation.
It's the humble acknowledgement that a dozen executives sitting in a boardroom cannot accurately predict where the next major technological breakthrough will come from.
Top-down planning is inherently limited by the imagination of the planners.
Exactly. But if you hire thousands of intrinsically motivated, brilliant people and give them unstructured autonomy, they will build tools to solve their own problems.
And those internal tools often become massive global products. The track record of 20% time is absolutely staggering when you look at the early days.
It birthed the modern digital landscape.
Give us some examples.
Well, Paul Buchheit created Gmail.
Oh,
At the time, webmail was dominated by clunky interfaces that offered 2 megabytes of storage.
2 megabytes.
Right. Buchheit, working on his 20% time, built an AJAX-powered interface with a massive 1 gigabyte inbox that utilized Google's search algorithms to find messages instantly.
That's huge. And then you have Krishna Bharat.
Yes, after the tragic events of September 11th, he was frustrated by how difficult it was to synthesize information across disparate news websites.
So during his 20% time, he wrote a web scraping algorithm to cluster related articles together.
Which evolved into Google News.
And Susan Wojcicki helped pioneer AdSense, the engine that dynamically placed relevant ads on third-party websites, transforming the economics of the internet.
During that hypergrowth phase, a massive percentage of Google's new product launches could trace their DNA back to a 20% time project.
It was the highest return on investment imaginable.
But then reality set in.
Yeah. As the company scaled from a nimble startup into a massive global bureaucracy with tens of thousands of employees, the magic of 20% time slowly started to die.
It warped into something that employees cynically referred to as 120% time.
Ouch. Why did that happen?
The mathematics of middle management inevitably destroyed the policy. Imagine you are a mid-level engineering manager. Your entire performance review and your bonus is predicated on your team shipping a specific software update by Q3.
Right.
If one of your lead engineers suddenly announces they are taking every Friday off to work on a theoretical experimental mapping tool, you are going to panic.
Right. Here's where it gets really interesting. It's like telling an employee, we highly encourage you to compose a brilliant, world-changing symphony, as long as you do it on your lunch break while eating a turkey sandwich.
Exactly.
I want you, the listener, to imagine trying to invent the next billion-dollar technology platform in the margins of your already exhausting workday.
You are expected to deliver 100% of your core job requirements and then invent the future on nights and weekends.
It is a one-way ticket to severe burnout.
Because the 20% time was an informal cultural norm, rather than a formally protected metric in performance reviews, it couldn't survive the pressure of scale.
Managers naturally protected their team's deliverables over wild goose chases.
By the early 2010s, it was already in steep decline. And by the 2020s, especially after the aggressive efficiency mandates and industry-wide layoffs, pure, unadulterated 20% time was functionally dead.
Which provides an incredible lesson for any organization trying to foster innovation.
Oh, it's the lesson.
Autonomy drives innovation. But as you mature, you must formalize expectations.
Yes.
If you do not actively, structurally protect exploration time and build it into the actual performance metrics of your employees, it stops being a beautiful innovation strategy and devolves into a mechanism for extracting free labor from your most passionate workers.
Exactly. But the death of 20% time presented a massive problem. Alphabet still desperately needed that bottom-up, wild idea energy.
So instead of relying on an informal honor system, they had to build physical institutions to house and protect those ideas.
They built 2 completely distinct vehicles to do this. Area 120 and X, the Moonshot Factory.
Let's break down the difference between these two because they serve completely different masters. Area 120 was launched by Sundar Pichai in 2016.
It operates as an internal startup studio.
It essentially takes the ghost of 20% time and institutionalizes it. They literally brand it as 20% projects 100% of the time.
Instead of forcing engineers to moonlight on weekends, Area 120 formalized the pitch process.
Right. Twice a year, any Googler can submit a business plan.
If the pitch is accepted, that employee and their team are officially temporarily reassigned. They step completely away from their daily jobs.
And they get to work full-time on their idea with dedicated funding, office space, and mentorship.
The goal of Area 120 is going from 0 to 1, validating product market fit.
It's heavily focused on software, user-facing tools, and digital services.
And the successes that have graduated from this program are incredibly practical. Things like Aloud, an AI-powered pipeline that automatically transcribes, translates, and dubs video content.
Which graduated to become a core feature inside YouTube.
Or Tables, a highly collaborative database tool that got absorbed into Google Cloud.
Or Game Snacks, an HTML5 gaming platform built for low-bandwidth environments that was integrated into Chrome.
Area 120 is fundamentally pragmatic. Its mandate is to build software features that can eventually graduate and be reintegrated into the core Alphabet ecosystem, making existing products stickier.
It also acts as a vital talent retention valve, right?
Oh, absolutely. If you have a brilliant, highly entrepreneurial engineer who wants to build a startup, Area 120 allows them to scratch that entrepreneurial itch with the financial safety net of Google.
Rather than quitting and taking their talents to a venture capital firm.
Right.
Now contrast that with their other massive innovation vehicle, X, the Moonshot Factory.
Launched around 2010.
And led by AstroTiller, a man who literally holds the official corporate title of Captain of Moonshots.
I love that title. If Area 120 is focused on iterative software improvements, X is focused on deep tech, material science, and attempting to solve humanity-scale problems over a highly uncertain 5 to 10-year horizon.
Furthermore, X is not explicitly trying to build features for Google integration.
No, their ultimate goal is to create entirely independent spin-out companies that address massive new global markets.
To put it as simply as possible for you guys, Area 120 is trying to build a better software widget for YouTube. X is trying to build a balloon that beams internet from the stratosphere.
It is the textbook definition of an ambidextrous innovation portfolio. Area 120 is bottom-up, preventing entrepreneurial talent from fleeing to actual startups.
Right.
X is top-down, creating options that could redefine entire industries. But they both serve the exact same structural purpose we discussed earlier.
They insulate fragile new ideas from the crushing pressure of the core ad business quarterly goals.
Exactly.
But here is the reality of X. If you are taking these massive sci-fi swings at humanity-scale physics and engineering problems, you are going to strike out a lot.
Have to.
And the crazy part, X celebrates the strikeouts, which brings us back to the story I told at the very beginning of the deep dive. Welcome to the Moonshot Graveyard.
The prevailing ethos at X is fail fast, fail cheap.
How did they enforce that?
AstroTiller established rapid evaluation teams. Their entire mandate, their only job, is to look at a new moonshot proposal and try to assassinate the idea as quickly and ruthlessly as possible.
They conduct rigorous pre-mortems.
They search for the critical flaw in the physics, the supply chain, or the unit economics before the company sinks hundreds of millions of dollars into it.
They shut down over 100 projects every single year.
It's a huge volume.
Let's do a deep dive into some of the most spectacular occupants of this graveyard, because the reasons they died are incredibly illuminating. Let's start with Project Loon.
Project Loon operated from 2011 to 2021. This was the famous high-altitude balloon project.
The ambition of Project Loon was staggering. The goal was to provide broadband internet access to remote, rural, and underserved populations globally using a network of balloons floating in the stratosphere, roughly 20 kilometers above the Earth.
And from an engineering standpoint, it was actually a massive success.
Yeah, really. Navigating a balloon in the stratosphere sounds like a nightmare.
It is. There are no propellers. You can't just steer it like a drone.
Right.
The X engineers had to build complex machine learning algorithms to predict stratospheric wind currents.
How did it move then?
To navigate, the balloon would pump air in or out to change its buoyancy, raising or lowering itself into different layers of wind that were blowing in the desired direction.
That's genius. And they powered the communication arrays with custom solar panels. They literally beamed internet to Puerto Rico in the aftermath of a devastating hurricane when the local cell towers were destroyed.
It was an absolute technical marvel.
So why did it end up in the graveyard?
Because of a ruthless evaluation of commercial reality. Over the decade that Loon was in development, the terrestrial telecommunications industry moved much faster than anyone predicted.
Ah,
The global expansion of 4G and the early rollout of 5G towers rapidly shrank the market gap of people without internet.
the ground caught up to the sky.
Precisely. And for the remaining populations that were still disconnected, the ongoing operational costs of Loon launching the balloons, managing the helium logistics, maintaining the ground stations, meant the service simply couldn't be priced affordably for the end consumer.
So it was a flawless technical achievement that failed the unit economics test.
So X killed it, open sourced the atmospheric insights, and moved on.
Okay, let's talk about a failure that was significantly more public and painful. Google Glass.
Oh, Glass. The Explorer edition launched to massive hype in 2013, and the consumer version was effectively dead by 2015.
Glass is the ultimate case study in ignoring social friction. The miniaturization of the technology was highly impressive for 2013, but they bolted a highly visible, forward-facing camera onto a pair of glasses.
Wearing a recording device on your face into a bar or a public restroom or casual conversation created immediate visceral social backlash.
People felt actively surveilled. It was so bad that bars were banning them, and people coined the term glass holes to describe the users.
It was incredibly awkward, the battery life was terrible, and the lack of product-market fit combined with the price was just fatal.
They eventually managed a quiet pivot, repositioning glass as an enterprise tool for factory workers and surgeons. But as a mass-market ambient computing device, it was a profound failure.
But this is where the story connects perfectly to what we talked about in segment 1.
Right. Think about the smart glasses Google announced today at I/O 2026, the Samsung partnership. What did they do?
They ripped out the camera, they ripped out the optical display, they made them audio only.
Just a discreet Gemini assistant whispering in your ear through stylish frames. They took a brutal, humiliating public failure from 2015, internalized the data about social norms and friction, and applied it perfectly a decade later to launch a product that people might actually wear.
It is institutional learning at its finest. A failure is only a waste of capital if the data is lost. If the failure informs the next generation of architecture, it is just an expensive research grant.
Which brings us to the most mind-bending failure of all, Project Foghorn.
Project Foghorn is legendary within X.
The premise was to develop a carbon-neutral synthetic fuel. They wanted to literally extract carbon dioxide and hydrogen directly from seawater and synthesize it into a fuel that could drop into existing combustion engines without altering the infrastructure.
Turning the ocean into gasoline.
It sounds like literal magic, but again, the crazy thing is the chemistry actually worked.
It did. They built a working prototype, they successfully extracted the elements and synthesized the fuel.
But they killed the project voluntarily in 2016. Why?
Because the global commodities market shifted. The price of traditional oil collapsed globally.
Sort of an economics problem again.
Yes. The team at Foghorn did the math and realized that based on the energy required for their extraction process, their synthetic seawater fuel could never achieve cost parity with cheap traditional oil in any reasonable time frame.
It was commercially unviable.
And this is where the story gets legendary. The team went to the executives, presented the math, and killed their own project.
Wait, so what does this all mean? They gave people a financial bonus for failing and killing their own project.
Exactly.
That goes against every corporate instinct ever. If I am leading a project and I realize it's going to fail, I'm going to massage the metrics. I'm going to hide the flaws. I'm going to drag that project out for another 2 years just to protect my salary and my ego.
Which is the sunk cost fallacy operating at a corporate scale. It wastes hundreds of millions of dollars, and far more importantly, it traps brilliant engineering talent in a dead end.
By explicitly offering a financial reward for a team to independently prove their own idea will fail, X destroys the ego attachment.
This raises an important question, right, about how we define failure. Killing Foghorn freed up immense capital and released a team of brilliant chemical and systems engineers.
Those minds were immediately redeployed to projects that might actually scale, projects like Waymo.
Exactly. Waymo, their self-driving success, is the crown jewel that graduated from X. Or consider Google Brain, the deep learning project that paid for X's entire existence and eventually merged into DeepMind.
The astronomical commercial and strategic value generated by those few massive successes pays for the hundreds of failures. X also killed Makani, a project attempting to generate wind energy using tethered kites.
They killed everyday robots, an attempt to build robots that could sort recycling and wipe tables.
Because they realized that hardware robotics in unstructured human environments was economically unscalable.
Right, and they rejected concepts like space elevators and teleportation.
But even the dead projects yield patents, talent, and spin-off tech.
Yeah.
And the engineers take those battle-tested learnings back into the core company to improve search or cloud.
It proves that Alphabet does not view innovation as some magical, sporadic lightning strike of individual genius. They treat it as a scalable system with a high-variance portfolio.
You build an environment where you expect 98 out of 100 projects to fail spectacularly, knowing that the two that survive will redefine the global economy.
And that systemic, unsentimental approach is the ultimate antidote to the innovator's dilemma.
So let's pull all of this together and synthesize the journey we've taken you on today.
It's been a long one.
It has. We started by looking at the incredible, frankly futuristic announcements from today's Google I/O. We're officially entering the Agentic era, with Gemini Spark acting as our proactive, cross-platform assistant.
And Gemini Omni redefining creative reasoning through conversational, physics-simulating video generation.
But the critical takeaway is the invisible, immense machinery operating beneath the surface of those announcements. Alphabet's enduring edge isn't magic.
No, it is a meticulously designed, continuously refined structural engine.
It is an engine fueled by massive, ad-funded resources that are aggressively funneled into custom-built, vertically integrated infrastructure from the TPU pods, the optical circuit switches, bouncing data off microscopic mirrors.
It relies on a structural matrix that deliberately separates the relentless pressure of the core ad business from the extreme fragility of new moonshots.
It operates on a deeply ingrained culture that incentivizes intellectual honesty and rewards early effort over sunk costs.
And it is guided by a calm, pragmatic leadership style that provides the vital psychological safety required to take massive risks without fear of immediate termination.
It is one of the most profound organizational achievements in modern business.
And as we transition fully into this ambient, AI-driven future, the lessons from their architecture are applicable to almost any human endeavor. But I want to leave you with a final thought to mull over, connecting the very beginning of our conversation to the end.
Lay it on us.
Today, we explored the capabilities of Gemini Spark, an AI agent explicitly designed to proactively handle all the busy work of your life, from brainstorming to ordering groceries.
Right.
We also discussed the death of Google's famous 20% time because humans simply got too busy to invent on the margins. But if these AI agents actually fulfill their promise, if they truly take over the relentless, mundane maintenance of our daily lives, could they effectively give us back our own personal 20% time? If you suddenly had the cognitive bandwidth and the hours of one free day a week returned to you, insulated from the busy work of life, what moonshot would you build with one free day a week?
That is the question of the decade right there. If the AI handles the friction, what do you do with the freedom? What is your personal moonshot? We want to enthusiastically thank you for joining us on this massive deep dive. Keep asking those big questions, keep exploring the hidden infrastructure behind the magic, and we'll see you on the next one.